afternoon. So I'm honoured to be here this afternoon to talk to you about the UK Biobank Research Analysis Platform, which I think has been an absolutely transformative step in enabling research at the scale which is required for the size of the data set we have, and also increasing equity of access to the data. I hope by the end of this you'll agree with me that it is the way forward for researchers. So the UK Biobank RAP is our cloud analysis platform. It's managed by DNA Nexus and hosted by AWS on their cloud infrastructure. I'm going to speak about how researchers can use this platform to enhance their research, and also a little bit about how we're addressing some of the inherent challenges in moving our research community from their established methods of working on premises, on their established pipelines, to the cloud. So the platform was launched just over 2 years ago with the aim of enabling better, more open and more equitable access to our science across our research community. So today it has about 5,500 users who are working across 2,700 projects. These researchers have access to our full data set, which sits at about 30 petabytes, and can analyze this using about 450 apps and 200 tools to support them. The RAP is available to all active UK Biobank researchers. If you haven't signed up so far, you can do so with the QR code. Maybe wait to the end of my talk. And I think it's also got an amazing community of researchers who are supporting each other, peer support in help with pipelines, with analyses, and with using it, which is really beneficial. So firstly, why do we have the RAP and why do we need it? So UK Biobank first opened to researcher access in 2012. The total data set was about 20 terabytes. The majority of this was in OCT scans, with tabular participant data only about 20 gigabytes. This data was available only through a download mechanism. Researchers got a unique download of the data required for their research. The first major increase of the dataset came in 2017 with the genotyping dataset, which was about 10 terabytes. And due to the popularity of this data, overnight really, it increased the size of the dataset researchers were accessing from gigabytes to terabytes. So 2 years later came the release of the first whole exome sequencing data on 50,000 participants. And this increased the data by 2.5 times, forming a data set of about 75 terabytes. And then the final substantial increase under the original download system was in 2020 with the next release of the whole exome sequencing. This brought the data set size well over 220 terabytes, with researchers reporting download times over 14 days to access the data in some cases. So this actually started to reduce access because particularly for those with slower internet speeds or less reliable connections, and it really demonstrated that on-premises data wouldn't be sustainable for all our future releases. And indeed, just 1 year later came the 200K whole genome sequencing data, in addition to further releases of whole exome to bring it to nearly the full cohort, which frankly just changed the scale of the data we have. It was a 25 times increase, bringing us to about 6 petabytes of data. At this point, these large data sets weren't permitted for download, but if we had permitted it, given the 2 weeks it took to download the whole exome sequencing, most researchers would be looking at about a year to get their hands on the data set. And now in 2023, the scale of the data has just changed again, with 2 weeks ago, the whole genome sequencing released for the full cohort. So that's quintupled the size of the data with our full data set, which is tabular data, imaging data, genotyping, whole exome, and whole genome sequencing data, rising to about 30 petabytes. So size of data is, of course, one of the primary challenges which we face, and it has been a major instigator for development of the UK Biobank RAP. The size of the data we have is huge, with the whole genome sequencing dwarfing the whole exome and imaging data sets, which are incredibly large in their own right. We want to ensure that there's equitable access to the data set, and that every researcher registered with us is able to access and use the data, even if they don't have the computational capacity to store 30 petabytes. We also want to ensure that the data is available, reflecting every stage of the analysis process, to enable transparency and reproducibility for analyses. And with a wide diversity of researchers and research challenges, the scalability of cloud computing ensures that researchers can access the most appropriate compute power for each stage of their project. If they're starting with a smaller data set with the tabular data, they don't need to have a supercomputer at their beck and call. So one concern often raised by researchers is that potentially moving to a cloud-only model of access for genetic data would limit the usability of the data for reproducibility in cross-cohort analyses, when similar restrictions on download or data movement have also been applied by other data controllers. So there haven't been a huge number of studies looking into this, but there's one 2022 study I'm just going to discuss quickly, which was a meta-analysis of GWAS for lipid measurement. So they're looking at identifying genetic variants which affect lipid metabolism, found very similar results, which can be achieved whether the raw data or the summary level data is used. So you have here the analyses with genetic variants on the x-axis, p-values on the y-axis, which is showing you how likely it is that the variant is associated with lipid metabolism. And you can see that the results are really very similar between the two. So these two types of cross-cohort analyses are also becoming more feasible with many large data providers, including UK Biobank, Genomics England, and all of us, using similar pipelines for data production. So we have joint calling and analysis of the whole genome sequencing data using the Dragon 3.7.8 pipeline, which creates very comparable data sets. So moving from on-premises compute and established pipelines to the cloud can seem a big lift for many researchers when they first start to consider it. So to support this transition, we have ensured that there's plenty of familiar tools to researchers when they are using the RAP. So we have Jupyter Notebooks and RStudio available to users. They can also visually interact with the data. So we can use a cohort browser to look at different interactions and frequencies of fields across the data, and also interact with the data using IDEs. For those who are ready to bring in large-scale processing, the RAP can run WDL workflows and really efficiently parallelize these across large numbers of jobs. And of course, researchers can still bring in their own tooling and pipelines and develop those in the RAP as well, in addition to using the hundreds of preloaded tools like GATK, FreeSurfer, and Planck. To further support researchers moving to the RAP, this year we've launched a public UK Biobank GitHub repository, which contains in-depth course teaching new users how to interact with the data. It gives a framework of straightforward code on which analyses can be developed. So this starts at the very beginning, teaching researchers how to subset the data, how to get the data from the tables and join it together to ensure that they have the right set for their own analyses, and develops on to advanced lessons such as producing and graphing principal component analyses from the genetic data. There's further tools on the GitHub we've provided to help with common tasks, such as setting the genotyping data to access a region or a SNP of interest. And we're really continuously developing the resources we have available. So if you have any specific feedback or things that you'd like to see, please do contact us or leave feedback on the GitHub itself. So outside of the RAP, there's other ways for researchers to interact with our data. So we have just launched the UK Biobank Allele Frequency Browser, which was developed by the Whole Genome Sequencing Consortium based on the 500K dataset. This is a public browser which allows anyone to explore the genetic dataset by genes or regions of interest. So you can filter by annotation type and level of impact, and each variant is then further broken down into ethnic groupings to explore population differences. This is a really great way to start to understand and explore the whole genome sequencing data before you begin large-scale analyses, and to understand whether the whole genome sequencing data is going to be worth bringing into or relevant for your current research projects. So if researchers are still wanting further support as well with looking at the research analysis platform and using the UK Biobank data, I'd really recommend the community forum, which enables a large amount of peer support. DNA Nexus also has documentation for all their platforms and some specific to the UK Biobank research analysis platform. And there's also a number of training webinars, so past ones are available on their YouTube channel, and you can also sign up for updates for when there'll be new webinars available and join live. One way we're also supporting researchers with access to the UK Biobank data is through the new Low and Middle Income Country Researcher Fund. So this supports researchers from LMIC settings by providing financial support with regards to their application fee. This has been supported by generous donations from industry partners, including AstraZeneca, Bristol Myers Squibb, Johnson & Johnson, and Regeneron. And you can register your interest by emailing the Access team, access@ukbiobank.ac.uk. And just finally as well, we also have AWS credits which are available to support UKB-RAP usage. So we have Getting Started credits which are available for a large number of researchers. These are £1,000 which are valid for 1 year. It can help you to understand what costs you might need for compute and storage over the course of your project, and then apply for enhanced credits in multiples of £1,000. These are valid for a year, and you can apply for them across multiple years. So there's a huge number of people who've helped develop and support the RAP. I'd quickly just like to thank my team at UK Biobank, Caroline Clark, who has put an enormous amount of work into this, and of course, DNA Nexus, but also our 500,000 participants without whom we wouldn't have any of this data. So thank you.